Welcome back to another series of lectures on mobile ad hoc networks. So we have the various lectures on wireless networks, and this connection in the future series of lectures are going to be handled on mobile ad hoc networks. So in mobile ad hoc networks, we are going to have the fundamentals as well as applications, challenges, features, goals, as well as the more concentration about the routing protocols, various types of routing protocols, and the transport layer issue. So as we know, these wireless networks are used for communicating as well as communication services when we are on the move. So basically, we have infrastructure-based networks, wireless local area networks, and ad hoc networks. So infrastructure-based in the sense, just like a cellular system, they need have base station infrastructure, and whereas wireless LANs, just like radio links or IRDA, and with very flexible within the reception area, just like ad hoc networks. Low when we compare with wired networks, these ad hoc wireless local area networks are having less bandwidth. Ad hoc networks useful when infrastructure is not available and when we have very short range or when we have, for example, up to if you want to establish a network below 10 meters range, it is not possible with the existing infrastructure. So that's why in that case it is possible to establish the ad hoc networks instead of maintaining or establishing a very expensive wired network or some other sort of networks. And these are used in military applications, rescue, as well as home networking. If it comes to cellular wireless networks, these networks are single hop wireless connectivity to the wide world, and whatever the space we have, that will be divided into cells, and a base station is responsible to communicate with host in itself when the mobile node is moving from one cell to another cell. That has to communicating with, that has to be connected with the corresponding base station or the tower. So handoff occurs when a mobile host starts communicating via new base station. And this is multi-hop wireless networks, and we may need to traverse multiple links to reach the destination. Mobility causes the route changes. If it comes to mobile ad hoc networks, so these networks are having host movement very frequently as well as the topology change very frequently. No cellular infrastructure is required and data must be routed via intermediate nodes. So if you consider the node A as well as node B, when always there are the frequent momentum of these nodes has to be changed. So depending on the changes in the node location or node mobility, so they have interconnection between multiple nodes. So these MANETs use multi-hop communication. So due to this multi-hop communication, we need to have the support of dynamic routing protocols. So there are basically two types of protocols are there: static routing protocols as well as dynamic routing protocols. So static means before transmission of the data only, it will check where the destination node is available. At the same time, how many hops are there in between source and destination. Everything should be evaluated and before transmitting the data. In the case of dynamic, on demand, when required, these protocols will react accordingly. So due to the mobility, we need to have multiple nodes in between source and destination. That's why we need to have a support of dynamic routing protocols. So at the same time, these mobile ad hoc networks is a wireless ad hoc network which is used to exchange the information in generally from one location to another location. So each node is willing to forward the data to the neighboring nodes or some other nodes. So it does not rely on the fixed infrastructure. So these mobile ad hoc networks are self-configuring networks of mobile routers and associated hosts connected by wireless links. So this union forms a random topology. Routers move randomly, very freely. Topology changes rapidly as well as unpredictably. So because every time the mobile node is moving from one location to another location, when it is moves, automatically the topology will be changed. So the standalone fashion or the connected to the large internet. These mobile ad hoc networks are suitable for emergency situations like natural or human induced disasters, military conflicts, emergency medical situations, etc. So these ad hoc network first before going to hybrid mobile. So what is the major difference between ad hoc network as well as mobile ad hoc network? So in this, we have the facility of increase of mobile applications and additional changes to the network topology and need to extreme network flexibility and rapid changes in network topology. So in combination of all these features, we can make mobile ad hoc networks. So these are self-contained. They can be tied to an IP-based global or local network. We can call this as the hybrid networks. So if this is one example of hybrid mobile ad hoc networks. So we have three vehicles and which are interconnected. When the vehicle is moving from one location to another location, so based on the we have, and again it is moving, so that this will be connected to the corresponding base station, and remaining two will be in ad hoc network. So like this, when they are moving into corresponding cell, that will be connected to the respective base station or the uh, tower. So when we go for history of mobile ad hoc networks, it will start with ARPA. You can call it as Advanced Research Projects Agency in the year 1962, and later on, which will initially which will be connected with various universities like University of LA and University of California, Santa Barbara, and University of Utah. So previously, these mobile ad hoc networks called as packet radio networks and sponsored by DARPA in the year 1970, Defense Advanced Research Projects Agency. So we will see what is packet radio. So these packet radio systems predated the internet and were part of the motivation of the original IP suite. So these experiments include the Survival Radio Network, that is SURAN project in 1980, later 1990, the inexpensive 802.11 radio cards for personal computer, and the current mobile networks are designed primarily for military utility. Later that will be spread to remaining areas. The examples include JTRS, Joint Tactical Radio System, and NTDR, near-term digital radio. Then why we need to have ad hoc networks? So setting up the fixed access points and backbone infrastructure is not always viable. For example, the infrastructure may not be present in a disaster area or the war zone, or infrastructure may not be practical for short range radios like Bluetooth within a range of 10 meters. So these ad hoc networks, no need of any backbone infrastructure support, and it can easily deploy and useful when infrastructure is absent, destroyed, or impractical. There are many applications where you can deploy mobile ad hoc networks like personal area networking, like cell phone, laptop, earphone, wristwatch, military environments, soldiers, tanks, planes, civilian environments, taxicab network, meeting rooms, sports stadiums, boats, small aircraft, where within a short range of area, it is possible to establish the mobile ad hoc networks. In case of emergency operations, also search and rescue, policing, and fire fighting. And as the other technologies, mobile ad hoc networks is also having various challenges like the limitations of the wireless network, which includes packet loss due to transmission errors, variable capacity links, frequent disconnections as well as partitions, limited communication bandwidth, broadcast nature of communication, and limitations imposed by mobility. So dynamically changing the topologies as well as routes, lack of mobility awareness by system and applications. So in case of mobility, there are some effects of mobility on the protocol stack. Due to this mobility, there are some effects on the protocol stack, like in application layer, new applications as well as adaptations has to be made. In transport layer, congestion and flow control. Network layer, addressing as well as routing, link, media access and as well as handoff, and physical layer, transmission errors as well as interfaces. And we have some limitations of the mobile computer: short battery lifetime, limited capacities. As we have, there is no fixed infrastructure and there is no power backup. We need to maintain the complete network with a short battery lifetime of that particular battery, as well as we have limited capacities. So if we come to features of mobile ad hoc networks, we have the autonomous terminal, distributed operations, multi-hop routing, and dynamic network topology, fluctuating link capacity, link weight terminals. So autonomous terminal in the sense, so both the whatever the mobile node we are taking, that node will be acting as a node itself as well as the router. So it will the particular mobile device will be acting as a node as well as a router. It will receive the data as well as it will return the data. Distributed operations, since there is no fixed network to control as well as management operations, which are distributed among the terminals we have in that particular network. Multi-hop routing in the sense, when we are sending the data from one node to another node, we need to have transmit the data with the help of multiple intermediate nodes. So there are that multiple intermediate nodes will retransmit the data which is received from the previous node. So that's why mobile ad hoc networks, as we discussed in the first slide, mobile ad hoc networks will support multi-hop routing. Dynamic network topology. So as we know, always these mobile nodes are changing, moving from one location to another location, so that when they are interconnecting with each other dynamically, the network topology has been changed among themselves. That is, they form their own network. Fluctuating link capacity. One end-to-end path can be shared by several sessions, as what the mobile nodes are with the same reason as the mobile nodes are moving from one location to another location. The links may be changed from from time to time. Like we terminate the sorry. The MANET nodes are mobile devices with less CPU processing capacity, small memory size, and low power storage. So uh, as the features we have in mobile ad hoc networks, we have some problems in mobile ad hoc networks, like in routing as well as security as well as reliability, quality of service, internet working, and power consumption. So these are the major problems in mobile ad hoc network. At the same time, we have some security issues. So in this, generally we have two categories of security issues: are the proactive approach as well as reactive approach. So in these two approaches are using to provide security for the mobile ad hoc networks. So we need to consider some issues when we are designing the mobile ad hoc networks, like secure multicasting as well as secure routing we need to provide, and privacy aware routing we need to provide, key management, and intrusion detection system. And these are the major issues we need to consider when we are going to design the mobile ad hoc network. That is secure multicasting, secure routing, privacy-aware routing, key management, and intrusion detection system. These are the major issues we need to consider to when we are designing the mobile ad hoc networks. And if it comes to goals, these are several goals like authentication, confidentiality, integrity, non-reputation, and availability, detection, and isolation. So authentication in the sense a node must know the identity of peer node it is communicating with. So without that authentication, an attacker could again gain sensitive information and interfere with other nodes. As we know, when we are sending the data from one node to another node, let us assume A and B, two nodes are there. When node A is sending the data to node B, the node A has to know whether node B is authenticated node or not. Confidentiality ensures certain information is never disclosed to unauthorized entities. That the data should be transmitted through authorized nodes only. Integrity means the message being transmitted is never corrupted due to before transmitting the data only it is checking whether it is authenticated or not. So that's why there is a less amount of chances are there to corrupt the data. Non-reputation in the sense non-reputation in the sense the sender cannot later that is deny the sending information and receiver cannot deny the reception. Availability means the node should be available to communicate at all the times, and detection and isolation means require the node has to identify the misbehaving nodes which are behaving not properly with the neighboring nodes that node has to be detected. So as we said, this is the packet radio network as we the initial stages of in mobile ad hoc networks, and that is this is initially first established for military applications. So that's why the image shows the military vehicles. So intrusion detection system uh, that already discussed. So these are some examples of Nokia Rooftop product. That is multi-point to multi-point mesh network to establish. We need to have one antenna and FHP Wireless and networking to internet. How these ad hoc network will be connected to the internet, and SkyPilot neighborhood SkyPilot network, which is located in USA. Okay, so next, so ants searching for food. So let us assume one ant was there, and that ant is searching for food. So in this case, what it will do is that ant is having several routes to reach that particular destination. So just like to explain more detail about mobile ad hoc networks, I have taken this example. So these all this ant is searching for food. That ant is having multiple directions to search. So in that, let us assume the ants are moving towards the food, but in between we have some obstacle. So these ants need to find some other route. So that's why. So some ants are moving like this, and some ants are moving in this direction. At last, they are reaching the food. So again, after taking the food, again they need to come back to their nest. So in this, there are three main issues are there in ants life. One is route discovery, and second one is route forwarding, and third one is route maintenance. So route discovery means searching for places where the food is available. Route forwarding means delivering the food back to home, and route maintenance is when food move to when they are moving to new place, they need to maintain that particular food. So traditional routing. So these are the fundamentals we have. In traditionally, the routing, if you consider this particular graph, so how the routing table was established. So if suppose there are the various nodes we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are the various nodes. And when the node 1 to some neighboring nodes. So here the neighboring nodes of 1 are 2 as well as 3. So from 1 to 1, if the source is 1, destination is 1, there is no next to hop. So that's why this is represented by empty. And I want to move from 1 to 2. Source is 1, destination is 2. The next hop is itself is a 2. The same way 1 to 3, the next hop itself is a 3. 1 to 4, I want to move to 4. There are two possibilities are there, either via node 2 or via node 3. So I will take the next hop as 3, and for 5 next hop is 2, for 6 also next hop is 2, for 7 next hop is 2, for 8 next hop is 4 or 2, for 8 next hop is 4, for 9 like this. For every destination node we will check what is the next hop. This was the routing table which was maintained at each and every node. So when the mobile devices are active, this mobile node has to send. If you consider the mobile node 2, frequently it has to communicate with node 1, node 4 and node 6, because to know the status about the neighboring nodes, in regular intervals every node is sending some beacons to its neighboring nodes, so that when it is sending the beacon, it will send the routing table to its neighbors. So in this way, traditional routing was maintained in mobile ad hoc networks. But later on, day by day, there are more number of routing protocols has been designed, and mobile ad hoc networks is very strong in routing protocols. So in next lecture, we'll discuss about the protocols we have for mobile ad hoc network.